Hello, my name is Bob, and I'm a tutor at Raritan Valley Community College's Academic Support Center. This is session 2 on our modules for the TI-83 and TI-84 graphing calculators. In this session, we're going to begin looking at how the calculators can be used for statistics. This is the first of several modules that will talk about statistics for the TI-82 and TI-83 calculator. This session assumes that you know some of the basics about the TI-83 and TI-84 calculator, such as how to input data and how to edit data, and the order of operations, or PEMDAS. If you need to refresh yourself on these topics, go back to session 1, modules 1 and 2, and review those before moving on. So now let's get started with these topics. The objective for this first module is to show how to calculate the mean and standard deviation using a proper formula, how to enter or clear lists, how to enter population or sample data into a list, how to perform basic list functions including sorting a list and summing a list, how to calculate the mean and standard deviation using one variable statistics, how to calculate 5-number summaries, and how to create box plots and histograms on the calculator. So let's get started. Our textbook, Introductory Statistics by Weiss, defines the mean of a data set as the sum of the observations divided by the number of observations. Let's look at an example. Suppose, for example, we had a statistics class with 16 students, and we wanted to find the average age of those students. Well, we'd take a look at our example and we'd enter those in one at a time, add them up, and divide by 16. Let's do that. So we have 19 plus 25 plus 22 plus 36 plus 22 plus 21 plus 28 plus 25 plus 24 plus 22 plus 23 plus 25 plus 33 plus 20 plus 19 plus 21, and we hit enter, and we get 385. We then hit the divide by key, and you can see the word answer pops up, bringing the answer from the previous calculation down to this line, and we divide it by 16, the number of students in the class, and we get the average age of 24.0625 years old. Now, if we had to do more calculations, such as standard deviation, we'd end up re-entering those numbers over and over again and doing some pretty sophisticated calculations right here on this home screen. We're going to see if there's an easier way to do that. And we can do that using the list functions of the TI-83 or TI-84 calculator. But before we get started, we've got to make sure that there's no data out there that we don't want. So let's go and take a look and see what's out there on the list data. And we do that by hitting the key stat, and we can see that the word edit is highlighted, and then underneath that, the number 1 edit is also highlighted, which is what we want. We'll hit enter, and you can see that there's some data out there that we need to get rid of. So let's try getting rid of some of that data. Let's say we wanted to get rid of the data in list 3. We can hit the key stat again. All right, and you can see that the 4th entry down under edit is clear list. So we'll scroll down to clear list and hit enter. And you can see on the home screen the word clear list came up, and we want to tell it what list to clear. So we're going to hit parentheses, and now we want to tell it L3. And we do that by hitting the button second and then L3, which is right above the 3, the closing parentheses, and enter. And the calculator says done. Well, let's make sure it's done. We'll go back and hit stat again, and we'll hit enter again, and you can see list 3 is gone. The other way we could get rid of list data is we could scroll up to the L2. So we'll scroll left and scroll up to the L2 and hit the clear key, and nothing happened. But when we scroll down back to the first entry, you can see that the list 2 is cleared. There's one other way to clear data, all right, and that is we can go to the memory key. We'll hit second memory and go down to option number 4, which is clear all lists. If you hit enter, you can see that clear all lists comes to the home screen. And we hit enter again, and that will clear all of the lists on your calculator all at once. So now let's go back and look at our specific data. And the way we do that is we hit stats, all right, and then we hit edit. We'll clear that list. And we're going to go over to list 1, and you can see we're at the position at the first entry under list 1, and we're going to start entering our data down that column. So we put in 19, enter, followed by 25, enter, 22, enter, 36, enter, 22, enter, 21, enter, 28, enter, 25, enter, 24, enter, 22, enter, 23, enter, 25, enter, 33, enter, 20, enter, 19, enter, and the last one is 21, enter. Notice if we scroll up to that last entry, you can see that that is entry 16 in list 1. So we have all 16 entries in that we want. Now if we wanted to add that data up, we could use a specific function called the sum function. Let's go back to the home screen, and remember we get to the home screen by pressing second quit, and then we'll clear that data from before, and we want to sum that list. So we want to go to a list function. We're going to hit the word key second, list. We're going to scroll over to the math function, and you can see that the fifth function down under math is the sum function. So we'll hit the number 5, which is another way of getting there. And you can see it says sum, and we want to sum list 2. Excuse me, we want to sum list 1. So we're going to hit second L1, a closing parentheses, hit enter, and you can see that we have our 385 once again. We can hit divided by 16, and we get back to our 24.0625 years of age as our average. So there's a way that we can use the list, and the data is still there to move along. Let's move on. Okay. Now suppose we wanted to find the median of that set of data. Well, the median of the set of data is defined as the middle numbers, and we need to put those numbers in order, highest to lowest, excuse me, lowest to highest. So what we're going to do is sort those numbers on the list. And we can do that by hitting the second list. We're going to scroll over to operations, and you can see there's a sort A for ascending and a sort D for descending. We're going to use sort A, hit enter. We're back to the home screen, hit list 1 again, closing parentheses, enter, and you can see that we've sorted our data, or you can't see it as the case may be. Let's hit stat and enter, and now you can see the data. We've got two 19s followed by a 20, followed by a 21, another 21, 22, 22, 22, 23, 24, and they're all in order all the way up through our last entry, which is 36. If you want to find the median of that data set, we look at the number of elements that data set has, 16, divide that in half, and we're looking at the 8th number. And because 16 is an even number, we're going to take an average of the 8th and 9th number. So let's scroll down on our list to the 8th and 9th numbers, and we can see that the 8th number is 22, and the 9th number is 23, and so we want to take the average of 22 and 23. Let's go to the home screen and do that. We hit second, quit, we take 22 plus 23 divided by 2, and we get the answer of 33.5. That's not what we expected, is it? Well, again, order of operations is important, and if you need to, we want to go back and review some of the earlier tapes where we talked about PEMDAS. Let's fix this so it's the right statement. We can bring that calculation back by pressing second entry. We're going to scroll over to the 22. We're going to insert a parentheses. We do that by hitting second insert and putting a parentheses in place there. Scrolling over in front of the slash, hitting second insert again, putting a closing parentheses in there, and now hit enter. And we can see that the median of that data set is 22.5. So now let's look at another basic statistic that we might want, and that's standard deviation. And notice that there are two different definitions of standard deviation. One is a population standard deviation, where you've got the you've got measurements on everybody in your population, and you can use the one standard deviation. The other is a sample standard deviation, where you've picked a random sample of students, and we're using that as an approximation of the real standard deviation. Well, in this case, we're talking about a class, and we've sampled everybody, so we've got a population standard deviation. And our formula is the standard deviation, or sigma, the Greek S, is equal to the square root of the sum of the individual observations minus the mean, that quantity squared, divided by n. Or there's an alternate formula which will give you the same answer. Sigma is equal to the square root of the sum of x squared divided by n divided by minus the mean squared. We're going to use that second formula, and we're going to use the list that we've developed to come up with standard deviation. So let's do it. We're going to hit stat, and then we're going to hit edit again. And in that second column, we want to put in x squared. We can do that by scrolling up to L2, and you can see at the bottom of our screen we've got L2 equals. We want L2 to be equal to L1 squared. So we're going to hit L2 equals second L1. We're going to hit the squared key, hit enter, and you can see we've automatically filled out column 2, L2, with the squares of L1. Now our formula says we need to add those up. Well, remember, we can do that by going back to the home screen, second quit, and we're going to do second list, scroll over to math, down to sum, and this time we want to sum list 2, so we hit second list 2, parentheses, enter, and we can see that the sum of the squares is equal to 9605. We need to divide that by our population, so we'll divide it by 16 and hit enter. Okay, and now we need to subtract the mean squared, so we'll subtract minus 24.0625 from our previous calculation squared. All right, that gets us 21.308 and change. And now we need to take the square root of that number. So we'll hit second square root over the squared key. We're going to hit second and answer on the opposite of key to bring the answer down from the previous line. Closing parentheses, enter, and our standard deviation turns out to be 4.616. So if we need to do that calculation, we can do it on the calculator a lot easier than we can do it by paper. Of course, there's one thing that we could do even easier, and that is if we don't need to show our work, we can just jump right to the answer. Wouldn't that be fun? Let's do it. We're going to get there by hitting the stat key, and now we're going to go over to calculate, and we want to calculate what's called one variable statistics. So we're going to hit enter. All right, it says one variable statistics. Our data is in list 1, so we're going to put parentheses, second L1, closing parentheses, and hit enter, and you can see all kinds of data comes out. Notice that the first thing is our x bar, and our x bar is our mean. It's 24.0625, just like we calculated before. The sum of x, 385, that's a number we've seen before. The sum of x squared, 9605, that's a number we've seen before. And now we have the two standard deviations. The sample standard deviation, which is 4.76 using a different formula, and in this case our population standard deviation, which is 4.616 and change, just like we had before. Notice that the n is the number of entries, it's 16, and in front of the n we have an arrow, which means there's more data there. So we can scroll down and see what additional data there is, and notice that we get the minimum, which is 19, or the smallest value, our Q1, or first quartile, which is 21, our median, which is 22.5, our Q3, which is 25, or third quartile, and our maximum, which is 36. So by entering that data in the list and using one variable statistics, we can get all that data all at once. Again, if we need to show our work, we can do it the way we did in the previous steps by doing the squares and showing it all the way through. And we can copy those answers down on our paper to demonstrate for either a homework or a test exactly how we came up with the answer. All right, let's move on to the next topic. So we talked in that last section about quartiles, and I think there's something important to mention right here, and that is there are at least 9 different ways to calculate quartiles. Statisticians do not agree on the proper way of calculating a quartile. In our book, again, Introductory Statistics by Weiss, the method is determined by finding arranging the data in increasing order, and we did that with the sort A command, and then finding the median, which everybody agrees on is the middle number. If there's an even set of numbers, the median is the average of the two middle numbers. If there's an odd set of numbers, it's exactly the middle number. And then the first quartile is you take all of the numbers up to and including the median, and then take that as a data set and take the median of that data set. And that's the definition that's used in Weiss. The third quartile, once again, what we do is take all the numbers starting at the median, including the median, all the way to the highest number, and take the median of that data set, and that gives us our third quartile. TI-83 uses just a slightly different method called the M&M method, named from Moore and McCabe, and they exclude the median point. And so we get slightly different answers. In large data sets, that really doesn't matter. But if you're doing it on a test here at RVCC or for homework, If you choose to use the calculator, make sure your instructor or professor allows you to use the calculated value. Otherwise, manually do the formula that's instructed in your book. Now let's talk about just a couple of simple graphs that we use a lot in statistics. And the first of these is a histogram. Now, if we want a histogram of the data that we have already loaded in there, what we can do is, first off, we're going to go to the y== screen and make sure there's nothing there. In this particular case, there are no formulas, y= formulas there, and that's good. If they were there, we'd have to clear them. Then we're going to go and hit second and stat plot, which is right above the y= screen. And we've got plot 1 is highlighted. We're going to hit enter. And now we need to make sure that plot 1 is turned on. So we'll scroll over to on, hit enter, and that turns it on. Then we'll scroll down to the type, and you can see that there are 6 different types of statistic functions. In this particular case, we talked about a histogram, and that's the third one over. We'll scroll over to the histogram and hit enter, and that turns the histogram on. Then we'll scroll down, and it asks for what list do we want, and again, we're going to use list 1, so we hit second list 1 to put it in there. And that's the data we want. We would go ahead and we can hit graph. And nothing's come up. Well, there's an easy way to fix that. And we're going to do that by hitting the zoom key. And if we scroll down to the 9th entry, there's 8 and there's 9, you can see there's a zoom stat function. If we hit zoom stat, there's our data going across the top. If we hit the trace key, you can see we start in the middle of the first bar, and it says the smallest value is 19, and the largest value, that goes to 22.4, and there's 8 entries. Scroll to the right, and we go from 22.4 to 25.8, and there's 5 entries. Scroll to the right again, we go from 25.8 to 29.2, and there's 1 entry. Well, that's neat, but suppose we wanted our bins to be a little bit more regular than that. We can adjust them. Let's go back to this window key, and we're going to have our windows. Let's have our first window start at 15. We'll have our largest window go to 40, and we're going to have our scale, or the size of our bin, be 5. Now if we hit graph, you can see that we've got a very different looking graph. Still a histogram, but if we hit the trace key, now you can see our first bin runs from 15 to 20, and there's 2 entries. Our next bin runs from 20 to 25, not including 25, and there's 8 entries. Then we get 25 to just under 30, and there's 4 entries. There's 1 entry between 30 and just under 35, and there's 1 entry between 35 and 40. So we can adjust the bins by changing the window on our histogram. Now the other graph that we have is called a box plot. And if we want to do a box plot, we would do just like we did before. We're going to hit second stat plot. We're going to hit enter so we can work on plot 1. We're going to scroll down to type, and we're going to go to our box plots. And that 4th box plot is the one that we want. That's a modified box plot, which is the one that you would see most typically in most of your classes. We're going to hit enter there. Our data is in L1, so we can just go and we can hit zoom 9 for stat plot. And you can see our box plot has come up on the screen. Again, if we hit trace, we start at the left-hand boundary, which shows our minimum. Scroll over once, we get to the first quartile boundary, which is 21. Scroll again, we get to 22.5, which is our median. Scroll again, we get to 25, which is our 3rd quartile. Scroll again, we get to 28, which is our 4th quartile. And then we have 2 outliers, which are 33 and 36. Now, if we wanted to do a standard box plot with outliers, we would again hit second stat plot, hit enter for plot 1, scroll down to type, and we would go down to the 4th entry, which is just a regular box plot, hit enter, hit graph, and you can see we get a different looking box plot where the outliers are not identified, and the maximum goes all the way out to 36. Hit trace, and you can see that the median stayed at 22.5, and we can move back and forth across the data. So let's summarize what we've reviewed in this session. We looked at our calculator, and we found out how to calculate the mean and standard deviation using the proper formulas, and we were able to do that using list functions. We learned how to clear a list. We learned how to put sample data into a list. We learned how to perform basic list functions like sorting and summing the list. We learned how to calculate the mean, the standard deviations, and the 5-number summary using one-variable statistics. We calculated 5-number summaries, and we created box plots and histograms. That concludes this session of Module 1.